I know you're normally chatty, but you're like a
Tomorrow's
whole new
Friday,
level.
you know what I'm saying?
Yeah, but you're like a whole new level of chatty, and it's not Friday.
You
know what I'm saying.
We went through the pain of buying online tickets.
That's nice. How nice. Okay. We need to go over these 2 math workshops, and then we need to talk about what I need from you today. So this is what happened yesterday. You had somewhat persevered through 3.1.2. We'll pretend that you actually did. 6 out another point. We'll pretend that your group actually did 3.1.2 and you actually worked really hard on it. There were 2 in the room who need to show me today that they've corrected 3.1.2 and they know who they are. We'll pretend that you and your group worked through 3.1.2. But I don't genuinely believe you and your group worked through 3.1.3. I believe that one person did all the work and you really didn't understand what was going on. And that's kind of going to be a slight problem for you today. So we need to discuss what happened and why Hunter was mad at 3.1.3. So I'm going to flip over. We'll come back to our workshop in just a second. In 3.1.3, the lady who runs this ice cream place, Jill, she changes her mind about something. So far she's decided okay, so she now has 3 flavors, 1 cone. And she decided chocolate, vanilla, and strawberry. Yeah, they're each their own separate cones. So that's how she got 3 for the 1 scoop. But if you made a list of all our options and you said, oh, chocolate, chocolate, vanilla, vanilla, strawberry, strawberry, and then you're like, but there are more options now that we have 2 scoops. You could do chocolate, strawberry, or chocolate, vanilla. You could do vanilla, strawberry, or vanilla, chocolate. Or you could do strawberry, chocolate, or strawberry, vanilla. So there ended up being 9 2-option cones. So it used to work that you would say number of scoops, so 2 scoops. There was 1 cone type, first scoop options. Oh, I did that wrong. You used to say I could just multiply and use the fundamental counting principle. So Hunter really wanted the answer, if you worked 3.3.1, he really wanted the answer on number 1 to be 12. And the reason is because he thought 1 cone type, the first scoop options, the different flavors, 5 take a point away. And then the second scoop flavors. So that's why he was thinking it was 1 times 3 times 3, which gives you 9. And that's why he thought this was 1 times 3, which gives you 3, because that's exactly how you were supposed to do 3.1.2. Agreed, you were supposed to use the fundamental counting principle. The fundamental counting principle fails you on 3.1.3 because Jill has changed her mind like a typical store owner. She's had a change of heart. She's finally realized that chocolate, strawberry, strawberry, chocolate are the same thing. So since these 2 match, we get rid of one of them. Strawberry, vanilla, vanilla, strawberry, they're the same thing. So since these 2 match, she gets rid of one of them. Chocolate, vanilla, vanilla, chocolate, they're the same thing. So since they match, she gets rid of one of them. So she actually ends up finding she has 3 duplicates. So instead of having 9 options for the 2 flavors, she only has 6. So that's why on 3.3.1, the answer is 3 plus 6, which is 9 for the very first question. And the second question ends up being 3 plus 6 plus 10 to give you 19. But if you don't actually have a picture drawn out with all the options, you're going to be at a loss today and off to a bad start. So if you were one of the ones yesterday who was just trying to get through the day, and I understand, trust me, I'm there, who didn't actually draw anything out, you're at a loss today because we're going to do probability of this. Like, what are the chances of me getting a chocolate? So, like, if we don't allow duplicates, I get it to 1 in 9 if there's 2 scoops. But if we're allowing, if we're mad at the duplicates, there's only really 6 options, so it's 1 in 6. So it depends. Are we allowing duplicates or not allowing duplicates? So if you didn't actually do something like this or really understand what went on yesterday, today the struggle is going to be real. Are there any questions about this? Yes, dear.
Not specifically about this, but do you have any videos on this? Kind of like that bridge video?
I'll look and see if I can find one, but I haven't seen one. But that's a good question, and I will look and see if there is one on YouTube. You can have a point for that. Yeah.
You think, did y'all give out worksheets yesterday?
No.
I wouldn't think it's
We just worked on the workbook.
Okay.
Okay. So if you drew this out for the 1 scoops, the 2 scoops, the 3 scoops, etc., then you're going to be great today. You literally can use your picture, and I don't care if you say, see my old picture somewhere for a lot of your, because you know I'm going to lift up the screen. And like yesterday, there's going to be numbers underneath. So Kaylee's going to know all the answers. But if the answer could have been found with her picture, then her day is just made easy. See my picture. See my picture. It's 1/9 because see my picture. But if Kaylee never drew this out, then there is no picture, so there's no see my picture. Okay, so let's do the 2 math workshops, then I'll lift up the screen and you go crazy. Not crazy. That was a bad thing to choose. That was horrid to choose in Discrete. That's not the words I wanted to say. They got to come back in now. Woo! I'm going to do the 2 math workshop questions, and then you're going to work on your activities. If you didn't show me 313 yesterday, that's okay. You need to show me today. You also need to show me 314. I'm not going to cry if you don't show me 315, but if you think Miss Compton's going to talk any more out loud about the vanilla and the ice cream scoops, I'm over it. I want to do something else tomorrow. I'm tired of talking about ice cream. So it's okay if you don't show me your 315 today. You need to show me tomorrow, but please don't ask me any more ice cream questions after today. I just can't. Okay. I just am so over it. After explaining to y'all in 6th period and the duplicates and the whoo, patience. Yes, dear.
What's your favorite flavor of ice cream?
I don't know.
No, your favorite?
I mean, I like chocolate chip cookie dough, but I've never said no to any kind of ice cream. It's ice cream. Okay, so you have 2 math workshop questions that you're going to help me get through quickly. 3 out of point. 2 out of point. 1 out of point. 6 out of point. 5 out of point. Ooh, never mind. Yeah, 5 out of point.
I'm doing my work right now.
I know, I realized that after I was hesitant. Okay, so I need help with these 2 math workshops so you can get back to your ice cream. The 1 math workshop is pretty easy. The second one, you actually need me to say some words. And I swear on the second one, we're going to keep it brief because we could go real deep and I just can't. Just can't today. Okay, so 13 is one you can handle. An irrational number is a real number within a radical sign. Is that sometimes, always, or never true? What's a radical sign? Okay, 2 and 3 get a point. So it looks like this. So if we put a number inside the house, is it always going to be irrational? Give me an example of one that's not, and I'll give you your point. 2 that ends up being an irrational number because if you type in square root of 2, it's not repeating, it goes on forever. So,
49.
why?
Because it's a square root.
Because it's a perfect square. 49 works the same way, so it's a perfect square. But square root of 3 doesn't work. So is it sometimes, always, or never?
Sometimes.
It really just depends on if it's the square root of a perfect square. If it's not the square root of a perfect square, then yes, it is irrational. If it's the square root of a perfect square, then no, it's not irrational. So it's sometimes, which is annoying because I don't like it when they're sometimes. I like one way or the other. That's okay. Hunter, you can get a point because you said sometimes. Okay, we're not going to overthink this. We're just going to talk basics on what you should be looking for if it was multiple choice. Because if this is a real-life ACT question, oh, goodness, it would take way too long. Okay, so there is a cone. 4, you can have a point now. There is a cone with a diameter of 6 and a height of 5, sitting with the vertex out to be partially filled with water through an opening at the vertex. What is the volume of the water in the cone in terms of the height of the water? We're not even going to solve all the things. I just want to know a couple basic stuff. I need to know the formula for volume of a cone. Does someone know the formula for volume of a cone? There's an H. There's a third. I heard you, but you were wrong.
1/3 times base over height. No, base times height.
There's,
1/3 R squared.
do you see how there's that circle at the bottom? That's how you know there's going to be an R and a pi. No, yours is for base times height times length is going to be just for like a cube.
Is there an R squared? There is an R squared.
Okay, so what stinks for you, what literally stinks for you, is that when I took the ACT, there was a whole sheet of formulas that I got to use. So when you take it, there is no formula sheet. So just first thing, I don't know. Why did they do it? Well, you know what? The good news is because they've done it this way, it actually ends up being in your favor, I think, in my mind. And here's why. Because when you get to the answer choices, if Hunter at least realizes, hey, I remember a cone is supposed to have a pi in it, in the volume formula, one of the answers is going to be missing pi. So if it has no pi, it's out. So just you knowing something simple like my answer is supposed to have a pi is going to eliminate one of the answer choices for you. And then otherwise, I don't know. So I agree. I don't really like it, but I didn't make it the rules. I just follow them. So I'd agree, but it is what it is. You'll have to protest the ACT people. I think their thought was no one in life hands you a formula sheet, so there are some you're actually just supposed to know and apply. But do I think you should know the volume of all the different shapes in life? Probably not. But this problem is a little more complicated than that. They don't actually want to know the volume of the entire cone. Because right now you would say it's a plug and chug because they told us the radius is 3. Like I know the radius is 3. I know the height is 5. So I just plug in 3, I plug in 5, I chug out an answer. But that's not how this problem works because it explains there's this water filling it up. And so what they really want to know is the volume of the water in the cone in terms of the height of the water. So meaning they need you to find the volume of the big cone, and then they need you to subtract out the volume of the tiny cone. So it really ends up stinking. And if you were to see a problem like this, there are 2 reasons why you might want to skip it. One, it involves similar triangles, which is geometry, which is most people's least favorite part of geometry. So you would have to recognize 3 over r equals 5 over 5 minus 8. You would have to set up a proportion and cross multiply. So that's one reason why you might want to skip it. And the second reason why you might want to skip it is this last little bit of the sentence. Because it tells you basically there is no hope. There is no hope. Because they're not wanting a number. So if you see a number that's like 15 pi, that answer choice is out too. That last sentence tells you they don't actually want a number at the end. What do they want?
The volume.
Well, they want the volume, and keep reading, in terms of...
Height of the water.
So literally, they're wanting a formula. They're wanting V equals, and they still want the 1/3 and the pi, and they like the H. They're mad at the R squared. They want a formula with volume that has H's, but no R's. So you're literally going to have to substitute in, maybe after you set up similar triangles, you find out that R equals H minus 5. It doesn't, but something like that. So everywhere you used to see an R, you would have to plug in H minus 5. And so something like that, so that would sting. So literally when I saw the last sentence, that's when I was like, I don't want to do this one. So there are problems like that. But again, you ought to be able to eliminate 2 just because you got some good guessing skills. And yeah, so Sydney sucked it up on this one, but she didn't waste all day on it. She moved on to another one and got her some points. Though you took discrete, baby, and I hate to break your heart, but there ain't going to be no questions about no ice cream cone combinations. Okay.